So, hi everyone, and welcome to today's online training session. So, today the topic of this training session will be how to manage photogrammetric production during peak season. So, as many of you may know, peak season means a lot of project, big project, short deadlines. So, today the goal of this presentation is really to show you um, some tips on how you can manage your photogrammetry production with Correlator 3D, how you can optimize your workflow. So let's start now with what you will learn today during this presentation. So we'll start by reviewing the project production challenge during the peak season. We'll also review the processing options of Correlator 3D to make sure that you have the good one that fits your workflow. We'll show you how to use scripts and batch processing to have a faster processing. Also, we'll talk about how you can manage large project and how you can split Correlator 3D project different based on the type of licenses that you have. And we'll finish with some real world scenarios, talking different project types and see what are the best way to manage such project. Also, we'll answer some questions at the end of this presentation. So if you have any questions, feel free to write them in the chat box during the presentation, and I will try to answer them at the end of the presentation. So let's start by talking about production challenge during peak season. So what are the main production challenge during the peak season? So summertime is usually peak season for photogrammetry. It's time to fly, time to acquire some images, but also comes with a lot of processing. So you can probably have a big numbers of project with some short deadlines, but also the size of the project can be quite considerable, and all those elements or those challenges can also affect the way you're going to process some of the project and how you're going to manage your deadline. So um, so let's see how we can get through those production challenge. So before starting, what elements to consider before processing your project? So the first one would probably be the admin requirements, such as the GPU you will use, the CPU you will use, and also the drive you will use. So basically, the CPU will be used for some of the modules. Some of the modules will use more core than other modules. Let's say such as the color balancing, which will use more core. Also, a good GPU is usually required with Correlator 3D since most of the modules are used with the GPU. And also another element that we usually tend to forget is your drive capacity. So having an SSD drive will significantly improve your processing timing, since the write and read speed of the input and output images is much more faster than on a standard normal disk. Also, by using GPU, it's a good thing to make sure that your drivers of your GPUs are up to date to make sure that you have the best processing capacities. Again, another element to consider before is the numbers of licenses that you have allowed. Let's say if you have a large numbers of projects that are due in a short deadlines. Well, sometimes having more than one licenses can help you to parallel distribute some project over multiple instances, or sometimes having, let's say, a floating license can help you with some modules if you want to do some seamless editing over different computers. This is also possible. Finally, one of the last thing we'll talk is the level of automation you want to have for your photogrammetric project. So there's basically three main options that we offer for the processing, such as the graphical user interface. You can also use some script with the automated workflow, and you can also use some script and run within the command line by calling Correlator 3D. And finally, the last thing to consider before starting your peak season is what type of workflow you want to have for your project. Is it going to be a continuous flow of images? It's going to be only smaller project. So all those things can influence the way you're going to manage your project with Correlator 3D. So first, let's talk by reviewing the processing option of Correlator 3D. First and foremost is probably the most used processing option, which is the graphical user interface. So basically, the graphical user interface will give you access to all the modules, and you're gonna have a full control over your data. You'll be able to fully play with the parameters to get the best result as possible. It's an interactive processing, so as you're processing your data, you will see the result showing on your screen as soon as a step is created. Also, you can run some automated work. You can create an automated workflow directly from the graphical user interface, and you can also run script within the uh, the GUI, which will allows you to have some good processing. So let me show you how it looks in Correlator 3D. So as we can see here, we have our visual interface of Correlator 3D. So basically, it's quite a user-friendly interface. Well, on the top, you have all your modules, which are ordered in a sequential order. So you're gonna have the open and close button, then you're gonna have the automated workflow, which I'll come back later in this presentation. And then you're gonna have all your different modules, such as the AT, the DEM generation, the ortho creation, and the mosaic creation, and finally, the 3D model generation. You can also perform your volumetric calculation directly from the graphical user interface if you're able to import correctly your 3D shapefile. And also, it's a good way to visualize your data to see if everything works well and if your project meets the accuracy requirements that are needed for your project. Then we have another processing option that we call the automated workflow. The automated workflow is what we call the one button click solution that's going to go through all the modules one by one. So it's a quick interface that can show you all the different options of the modules. And by selecting process, it's going to run module by module. And at the end of the automated workflow, you're going to have your outputs ready to be delivered or to have your QC done on it. There's also different profiles that are available for the automated workflow, depending on the output that you're looking for. Let's say if you're looking for true ortho, we have some profile for the true ortho. We have some profile for classic photogrammetry, which is usually the most standard one that's used. You can also uncheck some of the modules in the automated workflow. So let's say if you want to run maybe the arrow triangulation by the graphical user interface, you can, and then once you're sure that you have a good AT solution, you can then jump onto the automated workflow and generate the rest of the processing options, which can be run overnight and also gain some time because overnight processing is something that's really important when you have a lot of project. It's a good way to manage short deadlines if you're able to get your data processing overnight. Also, there's customized options, so you can play with the parameters, you can set your own resolution, and also the result are displayed directly after the processing. Finally, the options that I like the most about the automated workflow is you can directly generate some script from the automated workflow, which is a good option if you want to start scripting with Correlator 3D. Without having to write the script from scratch, you can then directly generate a script from the automated workflow. So so if I show you how it looks, well, basically the automated workflow is the button over here, and if I select it, I have multiple options, and I can specify some of the options. I can disable some modules if I only want to run a specific module. And as I was saying before, if you want to generate a script without having any processes, you can just check the box below, generate script, no processing, and it will generate you a script with all the different modules. And you can also then edit those different options if you want to have more control over your data. The other and the last options we offer for Correlator 3D is running Correlator 3D without having the graphical user interface. So it's by using the command line. So you can call Correlator 3D without having to open the software. So you can call your script. Um, you can call your script. The syntax, it's really intuitive, and I'll show you also all of the parameters that are available in the user manual. So basically, you create your script that contains some input. You can have some process, and at the end, some output will be generated. Also, another advantage of using script is that you can also add some other elements that are not related to Correlator 3D. So let's say if you want to move some folders or create some directories during your script to make, let's say, make a folder for your deliverables, everything can be scripted out within your bat file that we will cover later in this presentation. The command line, the script can be run from the GUI, or it can be run within the command line windows, or it can also be called, let's say, by another third-party programming language such as Python. So you can have your own Python script, which will do some cleaning in the images before, create your project, and then run your script directly into your Python script. So again, if you want to run a script within the graphical user interface, all you have to do is you can go into File and then run run script. So you'll be able to select your script that was either created by the automated workflow or built by hand. So yeah. So let's say how to use script and batch processing. So basically, the script is quite simple. So it's a series of commands that gonna contain every modules from the AT solution, from the project creation, up to the volumetric calculation, the export mosaic, the 3D model generation. So all of the steps that are available within the graphical user interface, it can be used in a script. So as we can see here in the user manual, you can see that we're gonna have a lot of parameters available for the script. So if you have, let's say, if you're missing a parameter, sometimes you can go back to the user manual if you want to see all of those parameters. So it also explain what of the options that are saying. Also, we have some pre-built script. So if you want to go into your Correlator 3D directories, so what you can do here is, let's say, you can create, you can go into your program files, into SimActive here, Correlator 3D, and you have a folder that's called sample file, which here is gonna contain an example of all of the modules by scripting. So you can start with this script to build your own customizable script. So one thing is, if you're planning to use the fully automated script without running the graphical user interface, you must think that the project will need to be created before. But you can create your project with the convert EO function within the SimActive installation folder. So the convert EO, what does this function do? So basically, the convert EO is basically going to create the EAO file, which is the main directory file we will need to process all of the modules in Correlator 3D. So the EAO file usually stores your camera parameters, your exterior orientation information, and also the way that the flight lines are built. So if you want to create this this EAO file without going into the graphical user interface, which does create the EAO file, you can call the convert EO, which requires the following elements. So you can call here, as we see, um, the convert EO function. You're gonna need the input EO file, so a text file that's gonna have the geotag of all the images, the projection system of this exterior orientation information, the unit, either meter or feet. Also the output file where we want to store the EAO file. The rotation system, such as the roll pitch yaw or omega phi kappa. And also, so the projection system, and here the EO system was probably longitude, latitude, or easting and northing. Finally, you will need the camera file and also a directory that point out to your images. So when you want to run a script from scratch without going into the graphical user interface, you'll have to first call the convert EO, then call your script that will use the EO file created by the convert EO file. So now let's see how you can loop, let's say, between multiple projects. So I'll show you an example where we have 3 small projects and I have some script and I would like to run one command, and then it's going to go through all the folders. So it's going to run the project number 1, then do all the deliverables. It's going to do after that the project number 2, and then the project number 3. So here, to do so, you can use what we call a for loop. So here the command would be, so for every folder in this directory, you can call a script that will include a convert EO, the script, and then a copy of the deliverable. And here, the %1 is set as a variable. So every time there's a loop that's done, this variable will change. So on the first iteration, it will be the project number 1. On the second iteration, it will be project number 2, and then on the last iteration, it will be project number 3. So let me see how it looks. So as we can see here, I would have here. I would have here my 3 projects. So project 01, which is my first project, that contains my images, my script, my camera, and my EO file, which are the main items I need to create my EO file. And then I have the same thing for my project 2, and then the same thing from my project 3. So I have all of those that are written here. So here, what I would have is 2 scripts. So the first script would be the go script, and then the other one would be the run script. So the go script is basically my for loop. So for every folder, in this path, which start by 0, so the 01, 02, and 03, because I don't want to loop into the deliverable folder. I do call my script run .bat or .txt, which in this script, this includes basically, first of all, the convert EO. So I have here the convert EO that's going to take the EO file, create my IO file, then going to call my script, and then copy my deliverables onto the same another folder. So this, on the first iteration, the number 1 will be 01. On the second iteration, the %1 is going to become 02. And on the third iteration, the %1 is going to become script number 3. So one thing here that's important is when you're using such variables, your script also needs to be pre-built with the complete path. If you want to also use some variables to edit your script every time, you'll maybe need to do a bit of modification, But this script assume that in your SPT file, which are your correlator 3D script, your output path names are fixed. So the everything is already is already built. So yeah, so this will run with all of those three projects, and at the end, what I will have is I will have everything transferred into my deliverables folder, and I'll be ready to do the QC on this on those particular projects. So now that we've talked a bit about how you can loop between multiple projects, let's see how you can manage a large project and see what can influence the way you'll set up your project and what elements to think before starting your photogrammetric production during peak season. So first of all, how to split a correlator 3D project. So there's many ways to split a project. So the first one would probably be to split a project before the 80 before the 80. This is kind of a challenging question because if you want to split before the 80, but you're gonna have a continuous block, you gotta make sure that you have a good overlap between both blocks to make sure that there's not going to be any shift between blocks, and everything's going to be good. It's going to be good during the DSM generation and also the ortho creation. So if you want to split before the 80, you got to make sure that you have here a good overlap, and maybe you can use some common ground control points between those two blocks. If you don't have any common ground control points, what you can do is you can probably process the project number one, then use the mosaic and also the DEM from the project one, and use those as ground control points for project number two. So this way you'll make sure that both projects are tied together, and you won't have any shifting problems or any photogrammetric problems during the rest of the processing. The other another way to split out a correlator 3D project will be let's say to run the 80 on one computer, so all your images are run onto the same 80. So this way you make sure that the 80 solution that you have is good for your entire block of images. I know it can sound sometimes big when you have thousands and thousands of images, but we find that it's one of the best way to make sure that everything is all good, and you won't have any mismatch between blocks junction. Then, if you want to split out after the aerial triangulation, what you can do is you can take the 80 results, then export the camera file and the EO parameters. And if you have access to two different licenses, you can use the exported EO and camera file, which are your 80 results, to create one project into one computer. Then run a DSM, DTM, and then ortho on a section of the big project, and then on the other computer disable the images that were used onto the first computer, and then run the ortho, DSM, and DTM. This way you'll have what we call a parallel processing approach. And then once your orthos are generated, what you can do is you can take all the different orthos, bring it back into the same folder, and then generate your mosaic to have a seamless color balance mosaic. Another options, if you want to have a faster processing for the seamline editing, if you have access to a floating license and you're processing large project, which sometimes when you're going to see during the seamline editing, if you have multiple blue blocks, which means that when a block is selected, you can do the editing only on that part. But if your project is stored, let's say on the server, which is accessible with more than one computer, the computer number one can select one block of the mosaic, edit the seamline, and at the same time, the computer two can select another block and edit also the seamline of this other block. So this way, you'll make sure that you're gonna have a faster streamline editing approach. If you have some tight deadlines, sometimes it can be a good way um, to manage such project. So now let's talk about some real world project scenario and what are the things to consider when you're gonna process process. So basically, when you want the first project will probably be the single mission small UAV project, maybe up to five to 600 images, which is quite small. What we suggest for such project is you can use the graphical user interface. It's going to be really quick to process, maybe a few hours depending on the machine that you have. You can also use some ground control points to refine the absolute accuracy of the uh, of the model. Uh, for this type of project, some things to consider. Basically, the quality control can be done after the project is done, so you can run everything with the automated workflow and do the QC once the project is created, since it's quite fast to run. And also, those types of project can be run with a small laptop. We don't necessarily need You don't necessarily need to have a good graphic card for such small project. So a big um, GeForce 760 or GTX 750 would probably be something good for such project. You don't also need a little bit of RAM. It's sure that if you have access to more RAM or a better graphic card, it's going to go much more faster. But for such project, what we usually recommend is having as a resources maybe a UAV pilot that's going to fly your mission, or a surveyor that's gonna take your ground control points, and probably a GIS technician that can run um, such a small project before handing out the deliveries to your customers. The second project scenario it's a bit more challenging. So we have more images. So let's say we have around 1,000 to 2,000 images. It was flown in a multi mission UAV project. So you did two separate flights to acquire your images. So what we usually suggest here is when you have multiple flights, especially for UAV, we suggest to break down those two flights into separate groups to give more flexibility to the aerial triangulation. You'll have to make sure that you have a good overlap between your both block of images. Then from there, uh, you can create a group number one for the first flight, and then a group number two within the graphical user interface. So when you set up camera groups, or it's the first step during the project creation. So you can add, let's say, if I show it to you here. So once you create a project at this step, you can you can create here multiple groups, so multiple camera and in multiple group. In this case, in the case where you would have maybe two cameras on the rig, you can put them into the same group. But as soon as it's two separate flight, we suggest to put them into individual group uh, for um, for having a faster and a better processing. Um, Processing such numbers of images, so around 1,000 to 2,000 images, depending on the setup that you have, it can take around one day or maybe a bit more on the really a standard PC. But you can significantly lower this time if you're having a good graphic card, SSD drive, and also a CPU with quite a lot of core. Um, some addition might be necessary to input some ground control points. If you have a lot of images to process and you want to have a short processing time, It's a good way to make sure that the DSM resolution that you will select for the processing is according to your needs that you have. Because usually the DSM generation is around 50% of the processing time. So again, if you don't necessarily need to have a high resolution DSM because you only want to generate some ortho, well, you can maybe lower a bit the DSM resolution, which can help to speed up a lot the processing. So such project can be run, let's say, on standard PC, so a good desktop PC with a good graphic card. I can go. We've written here the GeForce 760. You can probably go better than that, maybe with a 10 GTX 1060 or 1080, depending on what you have access to. Also, maybe a more bit of RAM, so 8 gig would probably be the minimum requirements, but you can have up to 32 gigs if you have access, because usually better is faster. And finally, for such project, you'll probably need a UAV pilot, a surveyor, and a GIS technician to process such project. But the key here is make sure that you have a good overlap between both missions to make sure that everything is well tied into one block of images. The real scenario number 3 would probably be a continuous streams of UAV project. So when we start about talking about the continuous stream, it can be interesting to start considering scripting for having optimal processing. So you can use, since it's always going to be the same amount of data and similar data, you can use script to accelerate the processing, and it can be run either within the command line or from the graphical user interface. The processing time is going to be quite good. It's always going to be a continuous streams of processing, so the output always going to be generated as soon as an output is generated. If you're using some script, another project is going to start, so you can have a good flow of production. Also, if your license is stored maybe on a cloud option such as AWS or Azure, you have to consider the upload and the download of the data. Also, if it's stored onto a computer, that upload and download gonna affect the processing capacities that you will have. The system configuration may be having access to floating license, so which means that there's always more than one license that's gonna run valuable script, and also you can do the quality control on different machines if you have access to floating options. So as I mentioned, you can run those such project on the cloud, let's say with AWS or Azure, as long as they have a GPU instance. And for such project, maybe it will require a system engineer to build up the setup on AWS or Azure, or make sure that the continuous flow of data is up to date. A GIS specialist to do the QC onto the output, and also maybe a technician if you want to have optimized script, depending on the language you will use. If you're planning to use, let's say, your correlator 3D script within a Python script. Then another case of scenario that we would have would be the real world project number 4, which is basically you have different blocks that are not continuous. So you have discontinuous area depending on the size or on the dispersion of those projects. It can be processed into one project if they're not really far from each other, but some of the modules use a continuous approach. So let's say if you're creating a DSM, sometimes if the project are too far one from each other, it can be quite challenging. However, if they're really far one from each other, you can split them out into different projects and then use the script that I've shown previously before um, to have um, to have a good workflow. So every project can be used with the convert EO that will create the EO file. Then you're gonna have a script that's gonna run all your project. And once this project is created, then you can jump to the next. It's gonna jump automatically to the next project. So maybe here, as resources, we suggest a GIS specialist was gonna do the QC on all the project, and maybe a technician that can run those such projects. Finally, the last project that we have is and the most important one. So it's large format cameras project with 10,000 images and more. So those projects can be quite challenging and can be resources demanding. So what we suggest here is if you have big project like this, you can do the AT on one single project, and then you can split out the project into different machines if you have access to multiple licenses. But if you have one licenses, maybe break down your project into sections. So if you have a big project, well, if you're processing into one file, it's going to create large output. So it's probably going to be more manageable if you're able to break down your project into subsection, which first of all is going to give you the opportunity to deliver quickly some blocks to the end user because you're breaking down the project into smaller section. So yeah. What's also really important here is really carefully looked at the aerial triangulation report, which is going to be the main step. So as soon as you have a good aerial triangulation, if your ground control points residual are fairly low and you're sure that you have a good AT, then you can jump to the next module. But it's really important since you're managing large data sets to do some QC at every step. So it's gonna be really important to do some good QC. For such project, also things that are important to consider: the disk space. When you're processing large project, please make sure that you have enough or sufficient storage space before launching a process to make sure that you're able to store all the output that are created. Again, since those large projects will require more time than a smaller UAV project, maximizing overnight and weekend processing is a key here. So you do your QC during the day, and once you're ready to leave the office, you launch your processes. It's gonna run overnight, and the next morning you come to the office, you'll have probably the output ready to be QC'd and go to the next step. So by using overnight and weekend processing, you're making sure that you'll lose as less time as possible for such project. The hardware requirements that we suggest for such project, maybe multiple licenses if you have really big project and you want to have fast deliveries. Good graphic card. So now we're talking around the GeForce 1080. You can also, we've seen really great result with the new NVIDIA RTX series, which it can be a 2060 RTX 2060. Also, an SSD drive will make a big difference here compared to a traditional hard disk. And for such project, what we usually recommend is maybe a project manager that can manage the deadline, see where we can have some issues, what happens if we have any issues, maybe a GIS technician or specialist to run and QC the data, and probably a certified photogrammetrist to make sure that the AT is good and the accuracy that you will be delivered is beyond the requirements that you have for your specific project. So again, here, Correlator 3D can bring you some unique benefits. So we have unmatched processing speed. We use most of the computer resources, especially the GPU and SSD, which are the two main things. We have different processing options. So no training is really required. You can start with the automated workflow, and as soon as you're getting more comfortable with the software, you can go within the graphical user interface, or you can learn how to script. So it's gonna be much more easy for you. You can run unlimited numbers of images on on a single PC. So as long as you have the processing power to do so, big things can be done with Correlator 3D. And also, everything can be batch processed, and with the command line interface, and also the software can be installed on cloud instance such as AWS or Azure instances. We offer also flexible pricing. We offer different types of licensing from the UAV, the medium format, the satellite, or the full format license. We offer monthly, yearly, or permanent licenses, and also node lock or floating options depending on your needs. So again, if you want to get started with Correlator 3D, feel free to write us at sales@simactive.com. We offer free processing for marketing purposes. Also, you can download your free trial of Correlator 3D on www.simactive. So again, everyone, thank you for joining today's online training session. So my name was Simon Grandin, and I hope you have a great rest of the day. Thank you.